About 2,500 years ago, a man named Democritus, he was a super rich Greek guy who basically had a lot of time on his hands and he would sit around and think about things. And one of the things he was thinking about was, let's say I have a rock, like this one right here. If I break it in half, okay, not quite in half, but what do I have? I have two rocks, right? So let's say I break it in half again, and it keeps getting smaller, right? I keep getting smaller and smaller pieces. I break it and I break it and I break it. Do I still have a rock? And Democritus said, sure. But eventually, you're going to get to such a small particle that it is the last time that it will be an actual rock. Like if you broke it again, you would destroy the essence of being a rock. You would be somewhere else. And he said, when you get down to that point, that's going to be called an atom. Okay, an atom is the smallest particle of something that it still retains its properties, its like essence. So we're going to represent those as, instead of like rocks, we're going to say that they're really tiny circles. Okay, so that really tiny circles, these atoms, make up everything, whether it's rocks or water or you or a table or these trees back here. They're all made of little tiny circles stuck together. And that's going to be the foundation of chemistry, and it's where we're going to start this year. So how do those little tiny circles give rise to properties? So let's take a look. Let's say the first property we talk about is the phases of matter. So matter comes in solids, liquids, and gases. There's some other phases, but we'll talk about them later. And let's start with solids. So this is a solid. How do we know that it's a solid? Well, it keeps its shape pretty much. If you could get a magnifying glass, you'd see that it has some long-term structure to it. This is a solid. These barbecue tongs, this thing is a solid. We know a solid when we see one, but the question is, like, what's going on inside the material that makes it a solid? And right now I showed you three different objects. We got like a can and some tongs and whatnot. Like the arguments that you could make would be really complicated because we've got different materials happening there, different shapes. So let's first narrow down our look and just check out water. Now, some of you may know that water is actually made up of different particles, but let's take ourselves back 2,000 years ago and just say that water is made up of water particles. And we won't worry about like whether that's true or not just yet. Let's just say water is made of little circles of water. Okay, check this out. So here we have my stove with a hot pot of water on it. And if you look very carefully, you can see some steam coming off of there. So we have up here some gaseous water. And then if we take a look over here, I've got some liquid water. So I could easily run my hand through the steam. And if you look, like when I put my finger in the water particles move away. I'm able to put my finger in and move them pretty easily. But then if we come over here to the ice, if I try and push my finger through an ice particle, like I can't do it. I can actually pick up an ice particle, and if I drop it, it stays as a chunk of ice. Where over here with the water, if I pick up some water, it forms drops, but then those drops take all kinds of different forms when they hit the ground. So the steam virtually has no shape at all. Here you have the water taking the shape of the container, and here you have ice taking a solid form that won't change. So the question is, why? What's going on here? Okay, so here we have a solid. I'm going to represent this solid as a bunch of atoms, a bunch of particles or circles that are tightly packed together like this. And I'm going to represent them that way because what I want to be able to say is, look, if I took my finger here and pushed downward, like, my finger's going to get stuck. So if I can't get that finger to go into that solid, because in order to make my finger get into that solid, I would have to push the atoms out of the way. There's no way for my finger to like slice through those atoms. There's just too much like traffic in there. So you could think about it as if there were a huge crowd of people and they were all like packed in really tight, and you wanted to cut through that crowd to get to the other side. It's really difficult, because if you push one person out of the way, you push them into another person who pushes that person into another person. And so pretty soon the whole crowd is pushing back, and it's almost impossible to move. So if we start thinking about materials in terms of these little circles, we can develop properties just by how we arrange the circles themselves. So in your first assignment, I'm going to give you this picture here, and I'm going to tell you that this is how I draw a solid. And I want you to fix this diagram so that you can make what appears to be a liquid and what appears to be a gas. And at this point, you don't know a lot of chemistry, so I'm just asking you to guess. Rearrange these circles, change the circles, make them bigger, make them smaller, add circles, subtract circles, whatever you want to do to try and represent a liquid and a gas. And again, it's a guess at this point, and I want you to explain why you chose that. Why did you make the changes that you made? And then we're going to start from there. We're going to take your ideas, and maybe somebody famous thought of them a couple thousand years before you did. And we'll talk about that. Good luck, and I look forward to seeing what you produce.